In this AstroPictionary physics math, we are going to solve kinematic x direction problems. For example, we're given a sports car comes to a complete stop from 30 meters per second in 4 seconds. We want to find acceleration, and we're given these equations at right, and now we need to solve. So we need to figure out which equation is best to use to solve this problem. So let's eliminate. Let's first of all find out what we want. We want to find acceleration. Acceleration is the letter A, so which one is the best one to use? Well, we've got an A here, and an A here, and an A here. Well, we don't have any accelerations in this equation, so we want to eliminate it. All right, so that's about as far as we can go there. We know we want to solve for acceleration. Let's go find out what else we've got. So we can see that we've got a meters per second, which is a velocity, and 4 seconds is a time. So that's two things that we have. Well, we have a velocity here and a time here, and we want to solve for A. This is a good one to use. This one's got a delta x in it, a v, a t. So we got the v, we got the t. We want to solve for the A, and we have the t, but we don't have the delta x. So this is not a good one to use. And the same thing down here because it also contains delta x. So we're not given any x information. We can't solve for it. So we're going to eliminate these problems. This is the one that we're going to use. So the equation, the real equation, I found this online. The real equation is, let me get a smaller pen. It's V final is equal to V initial plus A delta t. And this would be T final minus T initial. So now we need to find these values. Well, we know we're searching for A. We know we want A. So now we got to find V final, V initial, T final, and T initial. So let's start writing these down. We need a V final. We need a V initial. We need a T final. And we need a T initial. Let's go look and see what we've got. This is where you have to read the question. It says, given a sports car comes to a complete stop. All right, so let's kind of draw ourselves a picture here. We've got ourselves a car. Here's our car, and it's moving. So it's got some speed v, and we're going to start our clock here at time t equal to 0. Always start with a stopwatch. We got our stopwatch going, and our car sometime later is zoomed over here, and it says it came to a complete stop. So now we know that v is equal to 0. Came to a complete stop. And then we know that it took 4 seconds, so it took 4 seconds to get here. So on the right is my final values, and on the left is my initial values. So that's my T final, this is my T initial, and my V final is 0. So V initial has got to be this 30 meters per second. So now we've got our values. Our V final is 0. Our V initial is 30 meters per second. Our T initial is 0. And our T final is 4 seconds. Now we know everything. So let's substitute in. So we substitute in 0. I'll put it over here. 0 is equal to V initial, 30 meters per second. And now we have plus an A. We're solving for A. And now we need a T final minus T initial. So it's 4 seconds minus 0, or 0 seconds. So this is equal to 30 plus a times 4, because we really might subtracting zeros, nothing. So the first thing we want to do is we want to solve for a. We want a on the right-hand side. So I want to get rid of this 30. So I'm going to put minus 30 meters per second on both sides of the equation. And when I do that, basically I'm adding 30 meters per second to both sides of the equation, which is fine because it just really doesn't change the result. So all we have here is 30 meters per second minus 30 meters per second. That makes it 0 on the right-hand side. So we're left with minus 30 meters per second on the left-hand side. And that is going to equal the acceleration, which is what we're trying to solve for, times 4 seconds minus 0 seconds, which is 4 seconds. So we want to get rid of the 4 seconds on the right-hand side. Since I put the parentheses, this is multiplying. So once again, we want to, in this case, we want to divide. Since they're multiplying, we want to divide both sides of the equation by the same thing, 4 seconds, which once again doesn't change anything. And now we're going to erase like things, or not erase, cross them out. So we have 4 seconds on the right, crosses out with 4 seconds. Now we're left with a on the right-hand side. Carry our equal sign down. We got acceleration all by itself on the right-hand side. We have minus 30 divided by 4. So we go to our Google calculator and we say 30, or if you want to do minus 30, put the minus in there, 30. Now you got minus 30 divided by 4, and you get a value of minus 7.5. So now you say minus 7.5. Now we have a meter per second. So let's start with our meter per second. So this is in the numerator, this is in the denominator. Here's the 30 in the numerator, here's the 40 in the denominator, so the S must be in the denominator as well. Meters in the numerator, seconds in the denominator, 30s in the numerator, 4 is in the denominator. Therefore, seconds must also be in the denominator, and we add the second to the denominator. Now, instead of putting an extra second there, you can just put second squared because it's second times second. And here is our final result. Now, the negative symbol in here is indicating the direction to the left. And although I didn't declare it, it was already pretty much declared for me because I said the sports car comes to a complete stop 30 meters per second in 4 seconds. And I automatically drew everything going to the right. So therefore, to the right is positive in the positive x direction. And although we don't have a y direction, we'll just put it in here, up for y direction is also positive. Therefore, since I have a negative value, acceleration is acting towards the left, and I have a negative 7.5 meters per second squared for my acceleration.